Hello, my fellow coders. Welcome back to ThinkInCode, and today we are going to learn about error handling. So, what is error handling? Error handling means managing errors safely so the program continuously runs. So, what does this mean? Usually, right now, when our program is running, it crashes if we get an error. So, for example, if we do num equals to int, input a number, and print num, for now, just a basic example. And if we run this and we enter something other than a number, for example, this, we get a value error and the system crashed. So to handle this gracefully, what we did is made something called error handling. So now error handling helps us prevent crashing, improve user experiences, and help us debug and protect the systems and data. Now there are three types of error mainly that we are going to look through. One, we have a syntax error, we have runtime error, and logical error. Now logical error, we can't do nothing about it because it's just you, bro. Runtime error, this we can handle, and the same goes with the syntax error. We can't do nothing about it. It's just you. Now, when we have a runtime error, we could have different kind of runtime errors. For example, we can have file missing error. We can have a value error, and we can have divide by zero, and so many more. So to handle this runtime error, what we are going to do is we are going to use exceptions. Exceptions are a runtime error that can be handled, and the examples being same. This are the examples. How are you going to handle this? We are going to handle it using something like try, except, or exception method. And we have other things as well, something like try, except, and else. And we also have try, except, and finally. Now I'm going to explain all of them with an example. For example, try block, when we just use and except. So what's going on here is in the try block we are going to add our risky code. For example, if we go like num equals to 0, and then we do num equals to int, input, enter a number, and get a value error here, value error, and then we print something like enter a number, and then we do exit, right? Now let's copy this. Before we run this, what we're going to do is just do num equals to int, input, enter a number, and if we run this and we add something like this, it gets a value error. That's why we used a value error when we were using this exception. The exception is the value error right here. So we are going to use this. It means when we try this code, we might get this error. If we get this error, please use this. So now that's what we are going to do. And instead we are going to print num. Let's run this. We got please enter your number. If we do 12, then it will print 12 without running this. So that's what try except method is. Why do we use else? Here what we're going to do is instead of this here, we are going to do, and then if we do this, it's the same thing. Please enter your number, right? And if we do 12, we get 12. This means this is the success code. If we try this, right, this risky code, if we try this risky code, and then if it does not raise a error, then we will do this. So that is how you do try, except, and else. Now finally what we can do is this works anytime, error or not. So this code will run even if we get an error. If we look at it here, we do this. This code works anytime, error or not. Even if there was an error and we printed please enter a number, this code still worked. So what we can do here is for better error, right? And now if we print this and if we do this, even if there was an error, we got this output. Now if we print this and add a number, even if there was no error, we got the finally. So finally prints even if there is a code or not. So to give you a basic understanding, here is how you can understand it. Try is for risky code. This will include the risky code, the one that might produce an error. Now exception or expect will have a exception error here written, right? As this, we have done it right here, value error. Example, value error. Now next, okay, this will include a handle error code, right? That means how you want to handle error. In the above example, what I did was just printed that there was an error and you should enter a number instead. So how you handle an error, that's how You can print it, or you can run another function, or you can ask for the input again. And else is a success code. It's success code. If the risky code runs, then what should the success code do? And then we have finally, even if all of the above code fail, they should run. So taking this example, let's do a very important example. Let's say try num1 equals to int, input a number, print 10 divisible by num1, and then accept value error, not a value error. What we're going to do is zero division error, and then we're going to print cannot divide by 0. And then we are going to do another expect value error, print error, please enter a number. Or instead of this, to make it more professional, invalid input, please enter a number. So this is a 3-layer code. So as you see, risky code, we have this is the risky code where we divide 10 by num1, where the user could add 0, and this could be divided by 0. That's why we have error as exception as zero division error. That is the exception we might get, and we handled that properly by telling the user that there is an error. We cannot divide by 0. And another error or another case would be value error, where the user could add something else other than a number, and that too was handled here. Let's try it. Now in here, what I'm going to do is est error invalid, please enter a number. And if we have something like 0 cannot divide it by 0, if we have an actual number like this, we got an answer. So if we have like 5, yes, we got 2.0. As you can see here, 10 divided by num1 is 2.0. Now that is how you use error handling. And I have given a more detailed notes in the drive, so go check it out. And if you haven't yet, check out the whole playlist. It's right here on the screen, and I'll see you in the next one where we'll be making some error handling projects. Bye bye, happy coding, keep coding.